So first, let's just get ourselves familiar with how to run the tool itself. So basically, you first uh, do a git clone from the uh, uh, link Martin has posted in the chat, and then after
Vishal,
that,
is it possible that you please open the README, perhaps to give people like a quick
yeah,
overview?
sure,
Yeah, maybe start from there briefly and then thanks.
yeah. So as you can see, uh, so this is the thing I was talking about. The updated version is again version 1.2 RC. So the README is also updated only in this particular version, this particular branch. And as you can see, for this back to work properly, you need to have Xscheme and Klayout pre-installed in your computer. For Xscheme, I would say it's like better to use version less than 3.1.0, even though 3.4.1 is currently working, but still some minor changes have to be done so that you can compile it directly. But then otherwise, I would go with version 3.1.0 or something less than that. And for Klayout, I guess most of the I think the minimum version is 28.6, I guess, if I'm not wrong. And then there's this one inverter gen example pre-installed with the flow, which we are currently working on. Even though the other generators are in theory possible to work with this particular tool, our current focus is to get the DRC clean for this particular inverter, and then in future we are planning to get more generators up and testing more of them.
I believe this back frame that you say has to be completed. Currently, only some cells exist. It is NMOS, but also PMOS 4 LVT and PMOS 4 standard. I believe that is a kind of error, but probably
Yeah,
yeah.
even that is there. So
Yeah.
but for an inverter, I guess these things are enough for it to be functional. But then once we are done with testing an inverter, then we can even finish the missing components up from here, and then implement other generators. So yeah, that is one thing, but it's not of top priority right now. And then as you can see here, the instructions here are like pretty self-explanatory, I would say. You have to be a bit like I said, cautioned about the particular versions of these tools, because so that we are a bit more smoother than with newer versions. And then we do the pip installations, and this PDK installation. We are using this PDK manager called Volar, and this thing is useful for viewing the generated layout. And the steps here are also, I guess, pretty much self-explanatory. Same goes for the Xscheme PDK setup. You just have to make sure the Xscheme RC file is being the one is being run while you open the schematic file. And then for the K layout PDK setup, I think this is like an extra tooltip for us to get this to view the generated layout. But then apart from this, to set the bag itself, you need to have this particular command. If you could see here, this particular thing, I would go with the HTTPS one, because that seemed to be working, and that's what we have extensively tested. But this should also work, most probably. And then so once you do that, you first have to just source the open source me.sh file, and then use Python to run this particular command. So I guess we can have a demonstration now to show you the generated layout and how it actually works. So like I said, I currently have everything installed. So just for running the tool, I do source open source me.sh, And so this thing is going to set up all the environment variables, whatever is necessary. And then after that, we can, okay, let me search this command. Yep, here it is. So this particular command is using the the tool.py file, which is present in this particular directory. And then this is the pre-installed generator example that I was talking about, inverter1 underscore gen. There's also this particular inverter underscore gen, which is not kind of supported with the with this new way. So basically, this is the new way of running the tool. Before this, there used to be those make files and stuff like that, which was like pretty much complicated than this. So this is the easy way to do it. And so this inverter one underscore gen is the same thing as inverter underscore gen, but except for the fact that this thing works with with by running the tool using tool.py command. So this particular make argument tells our back tool to generate the layout and as well as perform LVS on it. So if you could see here, doesn't take long for it to run. And you could see the layout is written. And then this is the place where LVS is being performed. It explicitly invokes klayout and xscheme to give the reference design and extract the netlist from the generated layout and compare stuff. So as I said, the flow is LVS clean. You have the chances of facing this not being LVS clean if you use a wrong version of xscheme. So I would suggest, like as I said before, to go with something stable and older. And once LVS is done, we can also perform DRC on it. And once I think it's taking quite a bit of time. Yeah. So as I said, it's not clean right now, but then yeah, working on it. So the generated cell is this one. As you could see, this is not a pretty optimized structure because just for an inverter, it's using up almost like four metal layers. But yeah, we can definitely work on it. But the good fact is that the tool itself is working and it's giving us this generator. And also to see that the DRC is successful, we can use a markup browser, and then we can see that we have like 47 errors up here. So when you clone and when you run, you might have more number of DRC errors, but that's completely fine because we just didn't merge it with the main branch of technology definition submodule. So I guess yeah, this is like the kind of quick demonstration of the tool itself. And then I guess just for people who are curious about where exactly this a place to look out for while trying to feed in the DRC information, it mainly stays within this particular files, the files under the back technology definition submodule, the via parameters, MOS parameters, layer parameters, and init.py. So these are the main 4 files inside which you change the values, which are like kind of hard coded here, to make sure that the DRC errors vanish. So yeah, apart from this, currently instead of like changing values here, I have also started going a bit deep into the into the back end to see like how bag is actually generating all this stuff. So currently looking into how VRs are generated by this, because most of the DRC errors correspond to the VRs which are created in the layout. while I'm doing this, parallelly Martin is working on in more of quality of life fixes for the tool. And like he said, guess this is where we are right now, and we are hoping to push things quicker as fast as possible. Yeah.
Okay, thanks, Vishal. Sorry, do you have something more to add?
No, I was just asking if there are any questions or something where I can kind of
So Achilles, Jorge, if the mic is not working, can you type the question? I mean, everybody can see it. Do you have some question? I mean, there is one, but I think you already said you need to move up with your mouse, and then you will see this, the chat. If you move mouse up completely, but I can read it. So
hello. I think
yeah.
we have our microphone working now. Sorry.
Cool. Please.
Yes. Thanks a lot. Thanks, Vishal, for the presentation. So I didn't try this yet, but Achilles is here, and he apparently you tried it.
Yeah.
He has some comments.
Yeah, I've already tried the tool with the IIC OSIC tools environment of Harold Petrel and George Sago. But yeah, they have this problem that they are using the scheme 3.4. So we are out the dependencies, the requirements. So my question was more like, is there too much differences between the files that are generated with these two versions?
Basically, we were in contact last week with Stefan Schippers, the author of X-Scheme, because we noticed that LVS was failing with 3.4.1, but was working with 3.1 and 3.0. And so he already found the problem. He made some changes in the X-Scheme side. And we have, so the next X-Scheme release will, let's say 3.4.2 will then work again. But for now, if it would be best to use 3.1.0 because during LVS the X-Scheme is used to extract the netlist from the schematic, and in there 3.4.1 has an error that parts of the netlist, some parts are not exported correctly, and then LVS fails. So for now, it's 3.1 or 3.0 is required. But he already fixed this, and with the next X-Scheme release, it will work again.
Right. Thanks, Martin.
That was Vishal, I think.
No, that was Martin. Yeah.
Martin, sorry. I'm sorry.
I have a question or comment. Seems like a good work, but I have a couple of things related to these instructions that are written in the README file. So there's a couple of
you want to show that?
Observations. If you open the README file, or I can comment. So all those Git submodule stuff and Git dependency stuff, I suggest that those are handled with the script in its submodules that is already present in.
Yeah, that is working. So when we make some changes and when we want to clone or fetch a newer version of the open source DB template, once we fetch it to update the submodules, we can use the init submodule script. Even that is working actually. This is like we just mentioned one way here, so the other way is also working.
Okay, this is more like a management of management of how to say variance of different variants. If you do things, do it only with one way, because then you how to say, all the different things that you have or different ways of handling things should be documented. So if you have only one way, it's easy to document, and then it's kind of consistent. Then also this Python Python dependencies, there is this pip3 user install script that it's sufficient to say just run that. So you can add these dependencies there.
Yeah. Okay, maybe definitely we can make that update, I guess.
Yeah, then all the environment variables are handled with source.me.c, in this case source.me.sh script. Also, your you can put there checks for the required software if those are found in the path or not. And then if not, you can instruct with the script, you can instruct to install them.
Yeah, okay. That sounds like cool. So yeah.
So it keeps the README very simple, and the README should be just instructions how to run those scripts that do all these things for you, and how to run the generator. It keeps the structure simple. But these are my 2 cents on this. Good work. It seems to be good.
Yeah, sure. Thank you. Thanks for the comment. Yeah, we'll work on it, definitely.
Thanks.
Anything else?
I have one more question.
Sure.
How hard would it be to use other PDKs here? I mean, yeah, you are doing everything for Sky 130, so it's probably a lot of effort to. I mean, I don't know if a lot, but it's some effort to migrate to other PDKs. Do you have any comments on this?
Yeah. So the thing is that I'm kind of documenting whatever I'm learning from doing this, from trying to set up.
Maybe you can show this like via .py and whatever via there, and they can see that you actually commented design rules from Sky 130, so that you can have some sort of feeling where the dependencies are. Maybe not 1-to-1, but at least, Sky 130 we can share. I mean, we all have access to. Can you see?
Yeah, so these are the places where you could see I've kind of marked the DRC rule, which is getting affected by changing these values. But as Mariana said, it's not a 1-to-1 effect. Some of these parameters, like for example, these ones, the GateCon, this one and this one, are also trying to affect the way VRs are getting created, the width of metal layers making the VRs, even those are getting affected by this. So
they are design rule dependent in the end.
Yeah.
They depend on the design rule and design rules.
Right? Yeah. So that part is like it's that part is like a bit unclear. So I'm not like 100% sure as to like which of these parameters are affecting which of the end parameters. But all that I can say is like whatever we can change is all within these 4 files, like to migrate to one other technology. It's usually within these 4 files you can see here. The most parameters, via parameters, layer parameters, and init.py. But once I finish setting up this Sky 130 PDK, I should have enough information to to say exactly for this particular rule, this is where we have to change. So yeah, that would be documented. Yeah, definitely.
Okay, I see. And
in principle, it depends on how close the technology you want to enable is compared to the technologies that are already enabled with this flow.
Okay.
Because in the way how here different parameters are given, this is most of the cases a combination of different design rules from a technology. If you want to enable, for example, a technology that includes completely different concepts in terms of defining ground rules or what is needed for this specific process, then maybe it could be that you have to invent some new parameters.
I see. Yeah, because
for example, some simple examples. In most of the parameter definitions I saw, it based normally on a system where you say, okay, you have a minimum rule, and then you have maybe some steps. So width-dependent spacing rules or space-dependent width rules, something like this. So, but the way how this is defined here, this fails totally if you have a technology, for example, around 90 nanometer, 75 nanometer, where you have also something that is called forbidden spaces or forbidden widths. So, and this is something that is I don't saw so far that this is covered. So maybe Martin saw in the meanwhile something that goes in this direction, but yeah, it's maybe not so simple to enable then such technologies, for example.
I guess it would be hard to have something that is really working for all the technologies.
In principle, I would say what you need is you need more or less a concept for technology or parameter definitions that covers more or less all the different concepts you can find in technology around quarter micron, for example, so 250 nanometer up to or down to 130 nanometer, for example. So then I think with 110 nanometer, I think this was in some technologies one of the first nodes where you are facing the forbidden lines or forbidden spaces. So then you have also some, if you go in direction of FinFETs, for example, then you see, for example, that not all values are allowed for poly lengths, so for the gate lengths, for the transistors, for example. So, and yeah, it's something that's it's not so easy, especially when you develop here a concept only looking to one or maybe two comparable technologies, because then you are missing a lot. And here I'm only talking about CMOS technologies.
Yeah.
So there are also a lot of other technologies available, so GaN, for example, or whatever, that comes maybe with additional concepts.
Yeah, that's what I wanted to comment on. I invited also Felipe to this meeting, and he will be working with silicon carbide technology. So yeah, I guess that's a whole another world.
Exactly.
Just thinking if it would be possible to try to do, for example, one inverter in this other technology.
Yeah, I think a good first step is basically try to find out and understand the concepts that are behind the implemented parameter definitions. So, and with this knowledge, then the first thing I would do is looking directly to the design rule manual of a process where it's planned to introduce. So, and then make different checks and try to find out if the way how the parameters are defined here and also how the limitations are defined, if this is more or less compatible or it's possible to make a clear translation between the design rule manual from the technology to parameter definitions in back2. And the best check is if you come back from the parameter definitions in back2 to the design rule manual. If you see, for example, with the parameter definitions in back2, you cannot come 100% back to the design rule definitions in the design rule. Then it's the first indicator that you need some other or new parameter structures in the back2 definition.
Okay. I have one more question for Vishal and Martin. I didn't understand what the issues you have with DRC. Are they related? What's the origin there?
Basically, the spec technology definition is more or less sitting in between the PDK and the back framework, and it's telling the back framework about all the design rules, basically, and about the layers, the metal stack, and so on, but also about the design rules. So when the technology definition is refined enough, at the end, back will generate a layout that is DRC clean. But if they are not of a sufficient precision, then you will get a layout that has design rule violations. And this is exactly what Vishal is now working on, to refine in this back technology definition for Sky 130, to refine all the design rule related parameter definitions, so that back is able to generate a layout that is DRC clean. Yeah.
Okay.
So for every technology that you want to use, so there's the back framework side, there's the PDK you have installed somewhere in the system, and in between you need this, let's say, glue code there, which is the technology definition. And for every PDK that you want to use, you have to write dedicated technology definition.
Okay. So it's something that you understand, but it's just that you are working on this and trying to adapt the...
The problem is, so to say, that originally this technology definition was just a YAML file with very, very few comments. Then the next step was by Marco Kosunen and others, that they turned this plain YAML file into a programmatic classes with properties, where you can document stuff with doc strings. This is what's now basically open, such an example, where you have, instead of just having a YAML dictionary, so to say, you have classes that contain properties and contain doc strings. So now the idea is to improve this documentation, but at the current point, for Vishal, for example, you need to sometimes look into the back framework code that uses these parameters to understand how they are meant, because the documentation simply is lacking. And of course, our idea is then also in the process of getting this right for Carbon 30, all these comments that we have, that we also contribute them back to the technology template. So there's a back to technology template, which is the thing you would copy when you want to support the new PDK. And then you have a back to technology definition for your PDK. And the idea is that we include all these comments in the template, so that in the future it's easier then for people to understand how these parameters are meant and what exactly do they influence. But at the moment this is an ongoing process, because it's not always clear what is the impact of such a property, because the bag is simply not really documented enough, I would say. I hope this answers the question.
Okay. Yeah, no, it's good. Yeah. So you are sort of reverse engineering a bit the...
Yeah, sometimes you have the documentation is, so to say, the framework source code.
Yeah.
And you have to look at the source code where the parameters are read and used for calculations to get a grasp what the intention is behind the parameters. And sometimes this can be quite hard, sometimes it's easier, but yeah. For the future, of course, the goal is that all this knowledge that is obtained during this reverse engineering, so to say, that this goes into a better doc strings of the template.
Great. Yeah. Super. Thanks.
Any additional questions?
I don't have questions for now, but maybe just like a comment. It's very interesting what you're doing, and it would be great to, I don't know, contribute somehow. It would be nice to maybe demonstrate some design and even try to send it for fabrication at some point. I don't know, maybe even if it's an inverter. Be an interesting challenge.
Yeah,
so.
Jorge, for us. Sorry.
Perhaps just as a comment about this situation with the inverter, to explain, give a bit of background. So that the thing is with BAG, every, I would say, generator package consists of a couple of scripts generating the layout, generating the schematic in Python. And the other part a generator package consists of is a symbol and a template schematic. And in the original BAG2 flow, the symbol and the template schematic of a generator package would be an OA library of Cadence Virtuoso. So basically you would have a view, so you would have a cell like inverter 1, and in the cell you would have a view symbol and a view schematic, which is the input template schematic, which will then be patched and augmented during schematic generation. And the thing that now has to be done is, because instead of Cadence Virtuoso, for the schematic part, Xscheme is used, for the layout part, K-layout is used. So the input symbol and template schematic have to be represented in Xscheme. So that's what now Vishal has open. I think it's a bit small from my screen, but I think this is the this is the schematic, I think.
Yeah.
Yeah. So it's basically this is like a Xscheme. I think it's a Tcl more or less I guess it's more or less a tickle file, but this is the file format that Xscheme can open and read. And instead of providing with the generator package an OA library with symbol and template schematic, all that needs to be done now is to provide two Xscheme files, one for the symbol and one for the schematic. And all the examples, all the generated examples that we have, what we basically need to do is to convert these OA-based symbol and template schematic into these Xscheme-based symbol and schematic files. Then most of the layout generator part and schematic generator part are one-to-one usable.
Martin, question. Is it possible to have both?
Yeah, it's possible to have both side by side, I would say. That would be the ideal situation in the future, that we have in one generator package that we can install via Git as a Git repository, that we have both in there. And for example, in case only the OA is in there, the gen tool, for example, should report an error or could point out that this is not possible because it's not present yet. But I think this would be the ideal way, because most of the Python code for the layer generation and so is one-to-one the same thing.
Do you think the Xscheme schematic information would mess up the OA-based schematic information? If they exist in the same directory?
Yeah.
They will.
Yeah, perhaps we should do a follow-up meeting about this, how the generator package could look like, and how we could, what would be the canonical place to store these schematic and symbol files?
Because I think the, let's see, at least the Virtuoso doesn't react to the files it doesn't recognize. So you can put any files inside the instance directory. So if you just add those Xscheme schematic and symbol inside the same directory, then I think it should work.
Okay, yeah. Yeah, that was also something that I think Curtis recommended in the past. So that would be a way we could do it.
Second alternative would be to use different directories and then create a symbolic link to the valid one with the configure script.
Yeah.
For example. Okay, but this is good. Thanks.
There's also, there was one more question I had, because I saw that when Vishal was running the scripts, it was mentioning Virtuoso somewhere. So,
I mean, we have a to-do list, and this is part of it. Okay. We could clean up, so to say, the framework. Now the back two part of the framework is, of course, overfitting. If you want to Virtuoso.
So it's
lying.
You don't really need a running Virtuoso instance anymore at all. It's just that parts of the framework will generate log messages that are a bit misleading.
Okay, it was just.
And also there's this back server, so to say, for the inter-process communication with Virtuoso. There's a back server process started with a server port and so on, and this is basically not needed, but it might be that it's currently started. But you can ignore it. It's just a bit messy, so to say. It needs additional cleanup, but it doesn't mean that you need any Virtuoso at all.
Okay, great, thanks.
Hey, Jorge, I dropped, everybody can see this message to you, but regarding, when you said, okay, how can you help? Maybe some of your students can, repeat this, go through this README, try to go through all the steps. In the meantime, maybe this Martin will merge the Vishal's request so that you come up to the same number of DRC errors. And also we have not only just this inverter as a generator that is executed with let's say Xbase. We also have, Martin, correct me if I'm wrong, we also have, let's say, for sure, transmission. We have the complete two-stage, is it complete, Martin, two-stage op-amp that was taped out by Fatime?
Yeah, it's complete, but it's, of course, only in OA version at this moment. So what
Yes.
Marco said, what we said earlier, we would have to do this, so to say, for all the inverter packages.
Yes, but you know that means that somebody needs to make this template in XCAM. Am I right?
Mm-hmm. Yes.
But the layout generator can be executed. Of course, LVS cannot be done without it. But yeah, what I'm saying is, obviously there is a work that needs to be done, but also benefits.
Mm-hmm. And also with the, because currently we were focusing on inverter 1, which is basically analog based transistor level stuff. So what will be needed also, and what will be, if you use, for example, these capacitor related or resistor related cells that are part of this two-stage op-amp example, those will trigger, or those will affect other areas of the technology definition, for example, dealing with caps and dealing with resistors. And it might be that then also the technology definition needs some refinement when we test this resistor and capacitor related stuff.
Okay, yeah. That sounds interesting. Yeah, yeah, we were planning to send something for fabrication Sky in 130, so it would be maybe a nice target to try to do it through the OpenDB template, and maybe an op-amp would be a good idea. Then try to test it and to like close the full cycle, basically.
Mm-hmm.
Yeah, we'll also have a meeting with Harald Brettel tomorrow, and because he has this, you know, I think it was mentioned in the chat, this Docker image with all the IC-related open source tools in it. And at some point, we can also prepare to add this back to open source flow, so to say, to this Docker image, so that people don't even really have to follow the README, so to say, but already have it even easier accessible.
Yeah, that would be great.
Mm-hmm.
Okay. I can check here if if there's if it's possible to involve someone, because yeah, one thing is to say, okay, we will do this, we will do that, and something else is to be sure that someone will be involved in this for some months and like get to the end of the process. So I will try to find out if this is possible, and I will let you know.
Mm-hmm. Thank you.
But it's great work.
Any additional questions? Okay, then I will stop recording.